How did we go from an atmosphere of basically no oxygen to an oxygen-rich atmosphere? We can thank the early life for that. We would not be able to breathe in oxygen if the very original life on Earth didn't learn to photosynthesize, didn't evolve to photosynthesize. Okay? So because life was able to evolve and photosynthesize, that altered the chemistry of our atmosphere. And by altering the chemistry of our atmosphere, that altered what life was able to evolve on our planet. So we're going to see throughout the rest of the semester that the evolution of life and the evolution of Earth are very tightly coupled, with both of these things affecting the other thing. All right, so how did we get an oxygen-rich atmosphere? Well, this occurred around the beginning of the Proterozoic, which was about 2.5 billion years ago. At this time, some bacteria evolved this remarkable ability to take in carbon dioxide, which the atmosphere was chock full of, and convert that into free oxygen, which the atmosphere had basically none of, in a process that we call photosynthesis. Now, you might think to yourself, well, how do we know, right? We basically have no fossils of life from this time period. So how do we know? Well, even though we don't have a lot of direct evidence of the life, we don't have the fossils of those photosynthetic organisms, we do have evidence that photosynthesis was happening on Earth. One of the biggest lines of evidence is what we call banded iron formations. Now, these are rocks. And they can only form when there is oxygen in the atmosphere. Okay? Banded iron formations are ironstones that exhibit different bands of really dark gray colors to a brighter, dark rusty red color. And these dark rusty red bands are composed of mainly iron oxide minerals called hematite and magnetite. Now, hematite and magnetite, they can turn red when they oxidize, but in order to oxidize, oxygen must be present in the atmosphere. So when we see banded iron formations, or BIFs for short, when we see BIFs in the rock record, we know there had to be oxygen in our atmosphere. Okay. Now, coming back to our time scale, this figure is showing time as a circle, right? So starting at the top, 4.6 billion years ago, as you move clockwise, you see the Hadean, then we get into the Archean, then Proterozoic, all the way up till today. Okay. So this is when, in the Archean, this is when the start of photosynthesis occurred. Okay. So we're still, we're not even halfway through with Earth's time scale yet. Okay. So pretty early on in Earth's history, the photosynthesis evolved.